Hi everyone, we are Group 6 and my name is Ingnan. The topic of our project is Survey on MGWR. We will start our presentation with an introduction of geographically weighted regression, which is GWR, and a multi-scale geographically weighted regression, which is MGWR. Then we will cover the application for such regression, including various disciplines where it can be applied to, how we categorize them based on convergence standard, the measure of performance, and data processing. Finally, we end our presentations with other relevant methods. So first part is a brief introduction about three models dealing with geographical data. One of the most common used model is ordinary least square, which is also called OLS model. Geographically weighted regression model is proposed based on summarizing the local regression analysis and variable parameter research and drawing on idea of local smoothing. The formula is shown as below. Yi is the response variable. Beta j is the j's coefficient corresponding to the location. This will be in the form of a matrix to calibrate their model instead of proceeding a global estimate of each relationship in the model. It allows the relationships between the response variable and the predictor variables to vary spatially. However, GWR approach contains the local relationships within each model to the same spatial scale for all of the process in the model. In that case, MGWR is introduced. It allows the conditional relationship between the response and each predictor variable to vary at different spatial scales, and bandwidth is one of the most important results from this approach in the project. Here, it uses the bandwidth instead of beta j, which indicate how the different relationships operate across different spatial scales include global, local, and regional relationships, so bandwidth is the key to control the operational scale in MGWR. The second part is applications where researchers choose GWR or MGWR and analyze the data. MGWR can be applied to a number of disciplines to determine the most decisive factor of a phenomenon, like considering weights for different geographic location. Here, we have compiled a list of papers related to landscape, vegetation, climate change, analysis of business locations and price, public health, estimation of population, and even crimes and mortality rate. And the following section is our refined taxonomy. We have classified our literatures into these categories like convergence, standard, measurement of goodness of fit, data processing, and other methods. And here is our convergence standard. We classify our articles into this part, the SOCF, not mentioned, and others. There are three ways to measure the performance of MGWR. The first way is called coefficient of determination, or R squared. It is to calculate the proportion of the variance in the dependent variable that is predictable from the independent variable. It can be used to test the hypothesis, and it tells us how well observed outcome can be replicated by the model. It defined as 1 minus sum of squares of residential over the total sum of square. Well, the first sum of square is obtained by the summing up the square difference of the observed values subtracted by the mean, and the latter is key sum of the square of the residentials, which is exactly the second criterion, but with a different notation. As for archaic information criterion, it's based on information theory, which measures the goodness of fit. It's defined as 2 times the number of parameters, denoted by k minus the logarithm of the maximum of the likelihood function. However, if the sample size is small, AIC may select model with too many parameters, which causes overfitting. To address this, an extra penalty term for the number of parameters is added to the model, called AIC corrected or AICC. And here denote the sample size and n approximately the infinity. That extra penalty terms convert to 0 and AICCs convert to AIC. And this is our classification of the measurement. This is our classification of data processing. Utilizing reverse nearest neighbor strategy, we can handle frequently updated data on given location more efficiently. The performance of the proposed RNN-GWR approach is compared with the performance of a naive GWR and fast GWR approaches. Experimental evaluations show that RNN-GWR approach is computationally efficient than that other approaches on handling frequently updated data. And here is all of our presentation. Thank you for listening.